All right, let's get this recording started. All right, this will be a tutorial on how to mesh a PSST, which is just a square post with a bunch of holes in it. They're pretty common in real life, and in this assignment, we're asked to mesh this as well as a W rail. Or at least it's a rail with sort of a W shape to it. So this will just be the PSST one. So this is for homework 4 of MECH894, impact engineering. But hopefully this can just help anyone that might need it. So firstly, my screen is sharing. Okay. So firstly, I just downloaded the SDP file that Cody, our professor, provided for us. And then I'm going to open up Hypermesh. Hypermesh is the meshing tool I will be using, meshing software that I'll be using, just because that's when I initially learned. You can use prepost. Prepost is simpler to my understanding, but you can't do quite as much with it. Where Hypermesh definitely does have a learning curve, but you're able to do things that you can't do in prepost. Again, that's just my understanding. I've never actually used prepost. I've seen some tutorials, but that's about it. So we can get started. Also forgive any pauses. I've done this 1.5 times before, but yeah, this is still fairly new to me, but I did end up getting a pretty good mesh a couple days ago. So I wanted to share how I did that. So firstly, I'm going to just import the SDP file, which is just a file from SolidWorks to my understanding. I hope my sound is sharing. So here we can get a good look at it. You can press this button right down here, shaded geometries, to get like a better look of its actual geometry. So as you can see, it's just a square tube, plenty of holes. You can see these at like stop signs and stuff like that around here in Nebraska. So yeah, rounded edges and the plethora of holes kind of makes this a challenge to get like a good even meshing along the entire thing. So it's a challenge for sure. So for this PSST, we're actually going to mesh it as a shell element, which means it's going to be just like, it's not going to have a thickness. It's just going to be like the shape, which will be at the mid surface of what this would be. And then in pre-post or something else, we would actually like have that thickness as a part of it. So if you've watched the lectures from Cody in lecture 10, he kind of goes over shell elements. So I'll just read off a few things of why we do use shell elements. So it's most commonly used element in finite element simulations, just because it's an efficient use of materials, the controllable stress distributions, best energy absorption. So sheet and plate parts easier to fabricate than blocks or rods. So there's extensive libraries of tools, references, and best practices available. So I've just been told by my advisor Mojde to mesh these as shell elements, which makes sense because a lot of things that we do use are actually just shell elements. It's the most common to my understanding. So yeah. So firstly, we're going to want to create a mid-surface for this. And there is this tool. If you have a basic shape, you can just use this tool mid-surface, where you can, real quick, open this up. You can just click on it and do extract, and it's going to extract a mid-surface for you. However, since this is such a complex shape with those rounded edges, it's not going to do it correctly, unless for some reason it does. But as you can see, we can kind of just blank that out. As you can see, the mid-surface is pretty bad. The amount of precision that we want, this isn't going to do. So I'll just reject this, return. Well, I'll just delete this. well, I don't know why it is transparent now, but anyways, so we are going to create our own mid-surface then. All right, sorry for that pause there. I did, just to let you all know, I did back out and just re-imported it so it wasn't transparent anymore. I don't know, I thought that was odd. Um, in order to start this off, what you're going to want to do is go to the nodes tool up in this geometry part right here, go to nodes, and you can click this one right here, which is just going to place a node on geometry. What I do is I just click these nodes that already, or these points that exist along the geometry, and to get different different nodes going so far. So something that you're going to notice throughout this tutorial is that this is a bit tedious. There's a lot of parts to it and a lot of repetition, but you know, that's all right. So next tool we're going to want to use is interpolate nodes. So we're going to want to create a line on the inside of this, which, you know, is roughly the same as like the outer and the inner, but like in the middle. Because then we're going to drag that line out to create our mid-surface. So you can use the interpolate node one and click these two to interpolate a node in between. So you can go, keep doing that. Keep going like this. To get some nodes in between. And then for these edges, you're going to want to do, I believe it's this one. Hmm. All right, and then for this one, you're going to want to, again, interpolate some nodes, but we're going to want to have plenty along this curve right there. So I'm going to increase the number of nodes to 5 and do this on each of these lines just to get a good amount of nodes that I can then do interpolate nodes again and get that at the mid-surface. Again, that'll get us 4 segments on that corner, which should be good enough. So now that I've got those, I can go back to nodes. Make sure I'm recording. Yep. Okay. Nodes, interpolate. So again, if I remember right, I might have actually used a different process for this, but same end goal. Reading these nodes right here. And for these nodes, we're going to be able to draw lines in between them. Oops. I'm going to be able to draw lines in between them and then drag that line to create our mid-surface. So now we can go to the lines and just do this one, I believe, linear nodes, which is just going to do a linear between nodes. And for each one, you're going to want to click create. You want these to be individual. Don't want to rush anything because Hypermesh is weird and it will sometimes not actually create a linear line, or that's redundant, but it won't be linear. it will kind of be like what this mid surface did, where it'll look all funky. So yes. I'll pause the video for now. All right, so now I've got that entire midline drawn. So now for this, you're going to want to go to, you're going to want to go to 2D, and you're going to want to go to the tool called line drag. And so for this, you want to do this drop down, make it a line list. And what you're going to want to do is go click that line, that first for the line that you want to drag. And then you're going to want to do along this line because you want to drag it the long ways. And you can click drag. And if we hide this, you can see that it created that line, that surface. However, we're going to abort that because we do not want it to be meshed. So actually go down here and go to just surface only. We don't want a mesh created immediately because it will not be correct. This is the greatest answer to that question. So here we go. You can see that now we just have that line, that surface. So again, now that that's frozen off, I believe I can just use this line, drag, yep. So we just continue doing that along the edge until you have the shape that you want. All right, and here I am just wrapping this up. Oops. So again, I want to clarify that you want to do this for each line. Again, Hypermesh can get funky and can mess up your corners. So you can kind of see that since there is no like shaded regions, that this is in fact linear throughout its entire length, or it's linear and it doesn't, jut off in a certain direction at a certain angle. It is in fact the shape that we wanted. So now we can go and turn this shape back on and go to, so we're going to want to go back to that view and we're going to go to geometry and go to surface edit. So next thing we want is to actually get these holes out because that is important for a PSST. So we're going to use the surface edit tool again right here in the geometry tab. So we're going to want to use trim with lines, and we're going to want to use this one. So, and we're going to want to have normal to surface. You want to have that one enabled. In here, we can see that we want to cut with, we want to cut this surface, with these four surfaces. In the free lines, what we're going to want to do is go here, get in this view, and we can do just shift drag. So we can get all these lines and then right click all of these to exit out. What we're going to notice is, oops, that did not do it. All right, y'all, sorry about that. I realized I had my settings slightly off. So you're actually, for this surface edit tool, you're going to want to have surface edges to use as your cutting edge, not free lines, which I had before. So again, we can go back, select the surfaces. Oops, I messed that up again. So for the surfaces you want to cut, you're going to choose those four. And then for surface edges, you can turn this surface back on, go into this view, shift drag, and then right click these. And you're going to see that it selected all of these holes. So there's just a shortcut to get all these holes instead of manually clicking all of them. So I think technically you would only have to do this one and that one, because normally Edge, it's going to cut that surface as well since you selected it. Again, though, I don't really, it won't hurt if you do all four. So you can see all those circles are selected. Make sure I'm still recording, and I am. So then we're going to do trim, let it load here. And now we can freeze this, and we see we've got our surface with its holes, or the holes trimmed out, but they're not, the holes are still filled. So our next step is going to be to actually delete those. So we can go here. Oops, I don't know what I just did with that card edit. Okay, hopefully that didn't mess up anything. So we're going to go here. We're going to go this X tool. We want to have surfaces selected. And again, do that click drag on this area. Just so we make sure we have all that selected, but then right click these four to make sure we don't cut those out, and then delete these entities. So now we have our surface. Woo, okay. So this is what we're going to be actually meshing. As you can see from this view, it's, nice and clean cut around the corners with some, fairly roundedness to its corners. So yeah, so we're going to start with this. All right, now we actually have our surface to mesh. To do this, we are going to use the tool Auto Mesh, and we're going to want to choose a reasonable size. I did some measuring beforehand, but I'll show you some measuring. Generally, you don't want to have too large of mesh, otherwise you can't get all the details of the shape that you want. Excuse me. But you also don't want too small of shape, because then it's computationally expensive. A general rule of thumb is to not have to have your mesh the size of like your smallest element. I don't know exactly what that means. It would be that diameter of that hole, which was, again, I can select this. Oops, well, it's besides the point. Basically, I'm going to just show you that if we are going to use this auto mesh tool, we're going to use, so this is actually in inches, this PSST. So 0.1 inches. Generally, Moj, my advisor recommended don't use anything smaller than 2 millimeters as a mesh. So 0.1 inches. That's going to be 0.25 centimeters, which is going to be 2.5 millimeters. So that's about the smallest you're going to want it. And you get some decent shapes. Yeah, this isn't half bad, but you're getting a lot of triangles. But you get some odd places, and generally it's just not great. Along the face here. And you can also do these edges. We can just pretend that we want this. Click these edges too. So we're using like basically the minimum size, and we're still getting kind of funky meshing to it. Again, like it's not bad, but it could be better. So I'm going to just delete all of these elements. Meshes are classified as elements here. So delete that. So I'll still have my surface, but just no mesh anymore. So yeah, my previous one, I used a 0.5 size mesh, but I used a different technique and it turned out all right. But again, if you have too large mesh, you're not going to get the details you want. So I actually ended up having like a diamond shape hole right here, which isn't awful, but you're like really the minimum for like a hole is that you're going to want is like a hexagon. You're going to want at least 6 sides to that. I only had 4. The mesh looked good. I can actually pull it up for you right here. Just for sort of an example. Sorry for this tangent, by the way. Just wanted to show you that, you know, there is some thought process behind this meshing. So here you can see I've got the meshes. This is 0.5 size. They're all, you know, they're rectangular, but like each side isn't too much larger than the other, except for on these edges here, which is definitely a no-no, which is why I need to, again, still reduce my size. So I'm going to show you how to get here. Again, I apologize for that tangent. So we've got this surface. We can go in and first thing we're going to want to do, just take a side view. And we're going to want to go to the Nodes tab under or Nodes tool underneath the Geometry tab and choose where is it? Oops, okay. That's the wrong tab, wrong tool. I'll try to figure this out real quick. All right, y'all, sorry about that. I had to find that tool. It is under the Nodes tool, and you're going to want to use the Arc Center node. So you're going to do this at one of the holes, and you find that. So you now have a node at the center of that circle. And now we're going to want to translate or duplicate this node and send it somewhere in between, or like a quarter point, sort of, in between these sides. So in my previous example, I just did 0.5. Again, we can measure this distance, and we find that it's 1 2/3 inches crossed in on this face. So theoretically, we can actually just send it. Let's see. So I did confirm that a third, we're going to want to break these up into sort of a third or a quarter. I'm going to go in between that and just do 0.5 inches. Again, that's just what I did in the past, and it worked fairly well. So we're going to want to go to Tool, go to Translate, and before we click on this node, we're going to want to click on this, and we're going to click on Duplicate right here. And so when we click this node and we translate it across the x-axis, again, make sure this is the x-axis when you click it, and we choose that, well, that didn't work. Let me retry that again. Translate node. Let me click duplicate, click that, translate that. Okay, that's not working. I'm going to click it now. It is not duplicating. There we go. So there we duplicated that node, and we're going to want to duplicate that one and send it right there. So now we kind of have 3 different nodes to help break this up. And so in order to do this, in order to get a good mesh, we want to break this, I guess I should have explained this earlier. We want to break this PSST up into segments to where the auto mesh tool can't mess up really. And if it does, you can manipulate it in a few various ways to actually make sure that the mesh is good. and then you can kind of just do that on one face and then rotate or move the mesh onto the other faces. So for this, we're going to want to next, we're going to want to go to geometry, go to surface edit, and now we're going to want to use the trim with surfaces and planes, and we're going to want to choose the z-axis for this one. I think the default is that, but we want to choose the z-axis, and we want to choose the surface that we want to cut with, and the base node we're going to want to choose is this. So then we choose that, and it does a cut along that edge. And then we can also go to x-axis, I believe. So we go there, surface again. We want to cut that surface, or we can actually just cut all these surfaces. Go like this as a base node and trim, and it does that vertical line. Make sure I'm recording. Yep. So we are essentially going to do this along the entire face. Yeah. Now you can kind of just see you want to do this slide as well. Oops, we want to do this. And again, I should clarify that this is my method that I found out from watching just various YouTube videos, and I got a decent mesh out of it, according to my advisor, who also hasn't meshed a PSST in a while. But yeah, so in order to continue doing this, we're going to want to go back to the translate tool. We want to translate up the z-axis, and we want to go like this, and I believe it's 1 inch between the holes, and I should again press duplicate, click on that, and there we go. So we can continue by doing this, duplicate, and just keep getting nodes along the upper part of, or in the whole middle of these holes. So then we can continue making those horizontal cuts. So yeah, I'll do that right now. Alrighty, so I've done that. Just got to get rid of these extra nodes. Oops. Let me see, how do I do this? Well, that's unimportant. Those nodes aren't going to do anything, but essentially what I ended up doing is just duplicating all of these nodes just so I didn't have to take so much time, and just translating them up by 10 at a time, which is why, or 12 at a time, which is why I kind of ran over right here. Again, these nodes aren't going to do anything, although they are kind of just visually annoying. Let's see, there is no delete nodes, is there? Again, this is showing my my lack of knowledge in Hypermesh, that I don't know how to delete those nodes. But anyways, we can continue by just doing the same method we did before. Go to surface edit, tool, make sure we're on the z-axis, go to the surfaces that we want to cut. We want to choose all 3 of these, then base node, just this one in the center, and continue doing that up the face of this. Ooh, I wanted to bring up something important real quick. So I've only been choosing these front faces. However, to save time later, I'm going to actually suggest that we actually we can just choose all the faces, to be honest. Just so we can actually cut these side pieces, so that these side pieces, we force them to actually match up with these. It should match up when we mesh it, just so the end of one element matches with the other end of the other. So there's a 4-way intersection at these points. just to force it that ways. I have had problems in my other, when I tried to do it previously, so I guess I'll do that right now, show you how I'll do that. Again, this entire tool, oops, that's not what I wanted. Also, I'm zooming with the control and scroll. I should have clarified that. So surface, we just want to choose everything. And base node, well, we can just choose this for now because it doesn't matter. So that creates a cut along the entire surface of this, which will just be helpful for later in case we do need it. All right, so I finished up segmenting my PSST. Got with these nice little regions here. Again, I did those horizontal cuts around the entire surface. If you want to mesh each one the same way, you can. However, I'm going to show you a way where I just rotate my mesh along a point, an imaginary point on like a corner. So I rotate it like 90 degrees. So this one ends up on this face, or I duplicate it and I rotate it. So then I just have the same mesh on each one. You could theoretically, or not theoretically, you could just do the exact same method on all 4 faces and probably get the same result. I don't think there's any critical errors with my method. I just wanted to bring that up, that you could just do the same thing for the rest of these as well if you wanted. Also, I did look up how to delete these nodes. So you go here, geometry, delete nodes, click on them, and you go to clear. The more you know. So make sure I'm recording. Yep. So now we can get onto the meshing part. So I mentioned that we could probably go down to a 0.1 sized mesh. However, I'm actually going to do a 0.25 because as long as we get that hexagon shape, I think we're really sitting pretty. So yeah, I did get this to work fairly well with a 0.5. A 0.1 will definitely work. Again, it will be computationally expensive, so I kind of want to find that middle ground. So I'm going to just do 0.25 because theoretically, if I only had 4 sides using a 0.5 mesh, then I should be able to get about 8 if I half the size of the mesh. But anyways, I'm going to change mine to quads, my mesh to just quads. Some triangles may appear still, but yeah, and now we can kind of just see what happens here. So again, we get that. So that's not a very good mesh. We kind of want, our elements to be the size of squares, or approximately squares. So we're going to have to play around with this a little bit to see what we can do to actually get this to work out. Again, I got this work very easily with 0.5 size mesh. However, obviously this is looking a little bit more precarious than that was. So I'm going to just be playing around with these by right-clicking and left-clicking these numbers. I can change how many nodes intersect at this edge. So this looks fairly good. I don't like that little slant. Don't really know why that's showing up. So you kind of just, this right here is kind of like where meshing kind of becomes sort of a puzzle. You've got to make it look as rectangular as possible by, increasing or decreasing the number of nodes on a certain side. So yeah, that's what I'm doing right now. This is going to look very repetitive because, again, I am a novice at this, but let's see. Yeah, this is a bad mesh. Here, just as a reference, I'm going to open up my previous one with the 0.5 size mesh. Just to see how that worked out. If you remember, I only had 2 on each segment. So yeah, well, I had 3, and then I had, I guess only 1 element along that edge. So that's why that was a bit more rectangular. So yeah, this is a bit precarious. Let's try this one right here. So this is not what we want. We want these to at least be 2. Let's see how that looks. Not great. Well, that looks all right. Yeah, that's not half bad. What if we increase this to 2? Oops. Yeah, increase this to 2. So now we've got this mesh looking like this, and that's definitely solid. So yeah. All right, y'all. I was playing with that a little bit and figured this out. So with the 1/4-inch mesh size, we can get this pretty good looking right here using 6 on that edge, 3 on that edge, 2, 2, 2, 2. So we've got now, you can return, just kind of like accept. Now we can do these edges, see how this works out. We're going to definitely want 2 on each of those. Yeah, there we go. So again, this is just a puzzle right here. Essentially, make sure that's 2, increase that to 5. Yeah, now we've got this looking real pretty. Again, due to the whole nature or the nature of having a lot of holes in this element or this geometry, that it will look a little funky around the holes, but I think generally, these are square looking elements. So this is definitely a positive that we're looking at. Again, we've got these right here. So I'll just do this little bit right here. So yeah, 3, 3, there we go. And so we've got this face. You can essentially use this exact formula, if you want to call it that, up this face and do the entire length of the geometry. But also I'll show the edges real quick. You can just do 3, 3. And, that's a little less square-like. Obviously, it's a little bit at an angle, so the width isn't quite captured as well, but, that's really as well as we're going to be able to do. Yeah, by breaking it up into 3, that should be fine. So again, continue doing that. I guess I can post any redactions, if we want to call that, updated versions in the comments. Again, I had this checked, my previous one checked by my advisor. She said it was all right, but she did mention that I'd break these up just because I did have just a single element for this entire length when I had that 1/2-inch mesh size. I imagine bringing it up into these should be fine. But again, I'll post something in the comments if it's bad or yeah. So I'm going to just continue. I guess this brings up another point. Actually, for these, I think it's important to show you what it looks like, but there is a technique which I will get into later of how we can actually mesh these corners, but that I'll save to the end. So now I'm going to just continue meshing up this entire face, and I'll come back once that's done. All right, really quick, wanted to drop in to show you the technique that I'm now using. Just for reference, it's probably been 10 minutes that I've spent doing this. So this is pretty tedious and takes a while. But, it's got to be done. So what I did is I set this to 2. So this is going to set all the edges. So there's 2 elements per edge on all of this. So you can just click that and it does that. You can mesh it if you want, but then you just go to these outside edges, since these are both 5, and just give it 3 clicks and just go about it like this. And you will hopefully speed up the amount of time you're doing. So you're clicking less buttons, and the buttons you are clicking are just right next to each other, quite repetitive. And I'm just doing these a lot at a time since, again, saves the amount of time that I'm doing and spending on this. Since all the other edges are 2, I felt like this was a good method to do it. So there we go. Oh, this one is odd. Okay. So I guess I can turn this into a little troubleshooting lesson. Oof, I should have actually kept that open. So I'm going to just delete these elements. Delete these elements, go back. Oops, I don't know what I did there. Auto mesh, select this surface. So yeah, I'm actually gonna want 4 on that edge. Gonna want 2, 2, 2, 2, 5, 5. And yeah, so that edge is, is there some deviance from the others? Maybe, but again, that kind of just shows that this is a puzzle. There's some troubleshooting involved along with it, but usually it's not too bad in this meshing part. So again, go to this. I think I had 5 along there. No, probably 6. Yeah. Yes, that's 6, 2, 2. I have 3 along these edges, maybe. Yeah, there we go. So these meshes are a little bit smaller than those, but kind of just have to live with that. So now I'm going to start doing these. Oops. So this one should be a lot easier. Oh, I say that, but really just clicking those, clicking that, click that. So yeah, kind of just continue along with it on these edges till you have this entire face done. All right, so I'm nearly wrapped up here with this one. Just showing you guys my method for these outer ones. Real quick, I'll mesh these, set them all to 2. Since that left side is restricted to actually meet up with those other elements, that stays 5. So then I can just go along this outer edge, go up to 5. And keep this up. So mesh that. Again, have all we need there. Mesh this last one. I just need 3 and 2. There we go. So we've got a nice pretty face. face of mesh right here. The holes are octagons, 8 sides there, so that, you know, is solid. That. So now we're going to do the method that I was talking about earlier. We're instead of just doing this on each face, we're going to just rotate this mesh onto the other faces. Yeah, because it's been about a half hour since I've broken up those elements, broken them up into those boxes that I've just spent meshing these. And again, I've been taking some shortcuts. So if you were to do all 4 faces, you know, it would take you hour plus, even if you get really good at it. So yeah, we can go here and make sure which face is meshed. It's the bottom face. I don't like that. So I'm going to go like this. So the top face is meshed. If I click on that, double check. Yep, there we go. So real quick, what I'm going to do is I'm going to create nodes at the corners of each of these. So like this kind of looks like a corner, but I want it to be like, if I extruded this line out and this line out, I'd have that intersection right there. So yeah, again, I'm pretty sure this is 0.1245 out. I measured this beforehand. So yeah, from this node right here, I'm going to want to drag a line that's about 0.1245 in the negative x direction. So there we go. And you'll see that if I do that in the y direction here, positive y, nope, I'm going to want negative y. So these two will meet up at, you know, an infinitesimally small point. So just to show that this corner would meet right there, then we can go create a node at this intersection point. So click that line with this tool, the intersection tool, and do create. Oh, that didn't do what I wanted it to. Create. Okay, that's annoying. I'll figure this out real quick. All right, so for this one, I don't know why it was doing that, but for this, I just did node along, or extract parametric along this line. I just have the number of nodes set to 1, and I just did create and it biased towards over here, which is exactly where we want it. So now we've got that right there. I'll do it at this other edge too, just so when we want to rotate it to the other one. So we go node. We want it in the positive y direction. So there we go. You can go x-axis at this node, and we want it in the positive x. So right there. So how are we going to do this? We're going to go exact same thing I did last time. Right there. And then I just technically only need to do it for one more. Because once I rotate this mesh onto this face, then I can technically just rotate this one onto that. So I'll do this corner just so we're working clockwise. So we want to extrude this in the positive x. We want this in negative y. Again, I technically don't need to do both, I imagine, due to the method of not using the intersect and instead using this, but you know, it's really not causing any issues, just to show that it is indeed 1.245. So I'm going to delete these lines. Oops, I don't know what I did there. I was kind of freaking out there. Didn't want to delete something I didn't want to. So now we have these corners of rotation. It's probably an actual more official word for that, but corner of rotation is what I'll say for this. So we can see we've got the mesh right there. Yeah. Sorry, just looking at those. I don't really like this blue. Yeah, there we go. So if I use this, again, double checking that the mesh is on the top face. So what we're going to want to do is go to the tool here. Again, make sure I'm recording. Go to translate. So we're going to want to translate these elements since meshes are elements. And we're going to want to rotate them about, how did I do this in the past? I'll double check real quick. All right, sorry about that, folks. I was actually using the translate tool, or I clicked on the translate tool, so that was incorrect. Click on rotate. So we're going to want to duplicate these elements so we don't delete them, so we still have them on this top face. We were going to want to press original comp. We're going to want to shift drag all of these. And we want to rotate about the z-axis since that's into the page. Choose our base node as this corner node that we chose right here. And I believe since we are oriented the opposite way, we actually want to do 270 degrees and not 90. If we had y-axis facing up, then we'd want to do 90. But anyways, let's rotate this. So I guess I duplicated it wrong, but as you can see, I did rotate the mesh onto that face, and it is, it is perfectly aligned like that. So we can see how to do this right here. So yeah, I'll fix that and I'll show you once I have it all done. All right, and here we see I did now actually duplicate it when I rotated it there. So again, go back to that orientation, go back to rotate. This time I'll choose this one. Or I should duplicate visual comp and then do this and then just do it again for the sake of it. Original comp B, and I believe we're going to want to rotate 270 degrees again. Again, you can see that we have the mesh on top, right side, and bottom face, or in this orientation. So finally, we can rotate it one more time. Again, I don't know how this duplication tool or button works, so I am hitting it before and after I choose my elements. So this time I'm going to want to, again, probably still do 270 degrees, rotate it. No, that was incorrect. I did duplicate it, but that was incorrect. So I'll just Control Z that, return. So go back, go to rotate elements before and after for the sake of it. So I'm going to want to do just 90 degrees, correct? Let's hope. Make sure that's the right node. Yep, okay. And there we see it. We've got a mesh along all four faces. So now we can go back to just any orientation we want. And finally, we can mesh these edges, these corners. So for this, I'm going to go back to the auto mesh tool, surfaces, and just select these corners by shift dragging. You see that I just have those corners. So I'm going to mesh. And you can see from this orientation, oh, let's try this one. Let's try this one. Oof, so there's an issue there. So we need to increase the number of nodes on each side. So that, as you expect, will be tedious. So I'm going to try to figure out a way to where we can force it to match up with each side. I think I know how to do that, but just double check. Alrighty, I found out what might be the issue, or it's not really an issue. It's kind of just an oversight by me. So by editing the amount of elements actually inside of the like by changing how much elements were like on each side, which we were doing to make it look all nice and neat like this, we were actually manipulating the size of each element. So the auto mesher, we had the settings set to 0.25. However, yeah, so we had to set to 0.25 initially. I was playing with it, so that's why at 0.2. However, if we go to distance, we can measure the size of our nodes. So it's about 0.167 inches in that direction, while it's 0.2 in that direction. So our element size is a little, different, which is totally fine. Again, we chose quarter inch, yeah, 0.25 quarter inch mesh element sizes, but that's not really an issue. Obviously, you don't want to have too small, but again, you want to have a good element size. You don't want to be too small, otherwise it'll be too computationally expensive, blah, blah, blah. So in order to actually mesh this, I just figured out that, oh, the height is 0.2. So now I can go and use that same method that I was using before. Click and drag. Make sure I'm just selected. Oops, that's not what I wanted. Return. Go back to the corner. Auto mesh. Click and drag. So now I just have these corner pieces, and I changed the size to 0.2. Still just quads, but there we go. And it automatically just goes back to 5 and instead of 4, since our mesh was too big. We would have had to manipulate all of these, which I don't think would be a good use of our time. So there we go. Again, you can see it's a good mesh. Isn't doing anything too crazy. So we can go back and just start doing all these corners. Make sure we're just grabbing these corners, mesh that. And we do indeed have the elements matching up at the edges. So we can go right here, or do this one. Mesh that. And then one final corner. Yep, just right up there. And there we go. So now we can exit out all this, go to our nice pretty isometric view, turn off all of that stuff. So now we just have our mesh. I don't know why our mesh is just wired like that. I'll figure that out real quick just so we can have a good outro. All right, yep. So then we had this button selected. If we go like that, we have our mesh, and you can see that all the corners are looking good despite using that rotation method. We have, you know, I don't see how this could be bad. It definitely looks really good. Again, the corners we could technically use a smaller mesh size, but I think this one's solid. So yeah, I think I'll probably just wrap it up here. Again, this is just my method of how I did it. So this entire process took me a little under 2 hours. Um, so yeah, takes a little while to get all this done, but it turned out all right. There's probably faster ways to do it, more efficient ways. And again, if there's any issues with this, if we do actually need to run it, I'll let you know. But aesthetically, it looks good. It looks like a solid mesh. Well, a good mesh for a shell element. I should not use solid. So yeah, I'm gonna wrap it up there. If you have any questions, let me know. Yeah.